The BE1-FLEX can be used for almost any relay protection application. This webinar will cover how to make different applications and determine how to configure and set up the BE1-FLEX for almost any application. Instead of determining what relay to use, you can just configure the BE1-FLEX for your application requirements. So first, let's go over the agenda. First, I'll do a BE1-FLEX quick overview, and then we'll go through 4 or so application examples. The first one being a feeder application with basic overcurrent, under voltage, and frequency protection. The second example will be low impedance bus differential with a 4-breaker configuration. The next one will be a generator and transformer application with multiple breakers and multiple differential zones, all in one BE1-FLEX relay. And the last example will be a all-in-one, which will combine many of the above systems or applications into one BE1-FLEX application. And then we'll go through a quick HMI overview. The BE1-FLEX comes with a 7-inch touchscreen display. The display one-line diagram depicts and is configurable. Tools such as Inkscape can be used to make a one-line diagram that matches your specific application. The control push buttons can be used to operate breakers or other such items as a maintenance mode switch to enable a lower arc flash energy setting to enable instantaneous element with a lower setting to trip the breaker faster when personnel are working on the breaker. Programmable indicators shown on the bottom right section of the graphic display information on the home screen to give operators such as information possible about the overall status of the system. Quick link menu buttons at the bottom of the screen can navigate you to a screen with a detailed analog data of voltages, currents, phasor diagrams, and other information such as status of synchronization screen via a sync scope. This drawing here is the back side of the BE1-FLEX and the 7 available slots for different hardware. The power supply is always located in slot 1 at the top. The power supply also has an RS-485 connection along with an iRig-B input for a satellite cloud input for time sync purposes. Slot 2 can typically be a communication board with Ethernet communication, either fiber or copper via RJ45. Some of those communication boards also have inputs or outputs on them. The example shown here has 2 independent Ethernet ports along with 3 digital inputs and 3 digital outputs. One of the digital outputs is a Form C output contact. Slot 3 is for additional input-output cards, such as digital inputs, digital outputs, RTD inputs, analog inputs, and shunt inputs for DC protection. Slots 4 through 7 are for additional input-output boards and or for your analog boards for CT and PT inputs. So from a configuration standpoint, for selecting the options for your particular BE1-FLEX and its application, we provide this configuration tool on our website on the product page, as well as this same interface is in our BestComms Plus software. So when ordering the Flex, you need to complete the long style number at the top, and the same goes for programming the Flex. So with this tool, you select up to 4 analog boards. You select 1 communication board. You select the necessary input-output boards, and then go through the other options at the bottom right, such as the 3 power supply options, the terminal kit, the protection packages that are available from none, current only, voltage only, intermediate to enhanced, and the protocol packages, which have Modbus DNP3 and also IEC 61850 with Goose messaging, MMS, and file transfer. So for the protection packages, the Flex provides automation and control, combines a combination of elements, any number of elements, configurable elements with basic math functions, emerging markets with total harmonic distortion, and a no protection option. As you can see in the graphic, there is the no protection option, which gets you 62 timer virtual switches and some other items you can use. Then you can go to the basic current from there, or the basic voltage. If you move up to the intermediate package, that includes the basic voltage elements along with the basic current elements. And then if you go to the enhanced package, it enables all the protection available in that particular BE1-FLEX. With this capability, the BE1-FLEX can be upgraded in the field simply and easily via the protection packages with an encrypted firmware file. So you do not have to send the relay back to do upgrades. It can be done in the field. So Basler's BestComms Plus software enables quick, secure, and straightforward means to program the BE1-FLEX and most other Basler products. First, as we reviewed previously, you use the style configurator to select the hardware and firmware options you need for your particular application. After you make these hardware and firmware selection, the first thing you need to do is generate the configuration. What this does is it maps out the hardware based on the options you selected in the style configurator and creates circuits, breakers, inputs, outputs based on these selections. You can give the circuit a name and put in the CT ratio into the power system parameters. The next step for this typical overcurrent application, you would create a 50 and a 51 element, the instantaneous and time overcurrent elements, and then complete the settings for these 2 elements. This would automatically create targets, oscillography via fault records, sequence of events, and a security log. The last step before saving the settings file would be to drag and drop the protective elements and other logic you may need and connect them on the logic page as shown on the right side of the graphic. Once these steps are complete and you save the file, you're ready to upload the settings file to your new BE1-FLEX relay with a simple overcurrent protection scheme. So again, we'll go through 4 application examples. A feeder protection with basic current, over-under voltage, and over-under frequency. We will then go through a low impedance bus differential application with a 4-breaker configuration. We will then go through the generator and transformer multi-breaker, multiple differential zone application. And then last but not least, the all-in-one combining all the above into a single device. So the first application example is feeder protection. Feeder protection is used to isolate feeders and minimize damage to equipment. Feeders can be used in transmission systems, distribution systems, data centers, industrial facilities, hospital, office buildings, along with other applications. This protection also tries to minimize the loss of power to the system and only isolate the smallest portion of the system to minimize the effects on the system. So feeder protection purpose is primarily and historically 50 and 51 functions, so instantaneous and time over current. Faults cause damage to personnel, equipment, and disturb the system's stability. So feeder protection is minimized to design to minimize the outage zone affected and keep as much of the system in service as possible. Abnormal system conditions can lead to the fault, and reclosing is used a lot of times in distribution systems to try and minimize the duration of the disturbance by using the reclose function to isolate and hopefully get rid of the fault. When it recloses and go back in service, hopefully it stays in service and doesn't have to trip out and drive to lockout. So the last feature of feeder systems is the voltage and frequency reduces stress on the load, and voltage and frequency can be used to load shed during supply issues to the system. So here's a one-line diagram showing a 50 and 51 with a 3-phase set of CTs going into a relay with a substation breaker with feeder circuits downstream of it. You'll notice there's fuses there because the fuses are there to isolate a smaller part of the system to minimize the area of the fault. If that doesn't clear the fault, or it's upstream of those fuses, the main breaker will be isolated to isolate a larger portion of the system to clear the fault. Here's a typical thick feeder system showing a 3-line diagram and how you would connect it into the BE1-FLEX. On the bus side of the feeder breaker, there is the PTs, which are a 4-wire Y connection into the BE1-FLEX, along with the 3-phase CTs, for each phase, A, B, and C. And notice the polarity marks and how they're situated on the relay. Again, the first thing you would do would be to configure the options you need for your relay. Again, using the configuration tool in the BestCom Plus software, or the software configurator on the FLEX product page. As an example, for the prior feeder application, we'll show you this option on the FLEX product page. So you scroll down here on the product page to the configurator. On the left side shows a 3D version of the FLEX, and when you complete all the options, it will show what boards you will be getting and how your FLEX will look like. Over here, you scroll down and you select the number of analog boards you need for your particular application. That feeder application had 3-channel voltage and 3-channel currents. So I would select a T3 card. We don't need any other analog cards, so we can scroll up to the input-output cards. I would select typically the W9, which gets you 5 inputs and 4 outputs, 2 of them form A, 2 of them form C. We will select an E5 Ethernet card, which is 1 copper Ethernet with an RJ45 connection, along with 3 additional inputs and 3 additional outputs, 2 form A and 1 form C. We will then go down to the power supply and select power supply 1, which is 48 125 volts DC and 125 volts AC. The screw compression terminal kits, which are for the power supply and digital inputs. The analog connections are ringtone connections. Then I would select the protection package. For this particular application, as we reviewed earlier, we would need some voltage protection and overcurrent protection. If you're unsure of what protection elements are included in what package, you can select the I information button, and it tells you what protection elements are available in what protection packages. So for this particular application, it looks like you need the intermediate because we need basic voltage and basic current both. Then the same goes for the protocol package. If you're unsure, you select the I information button, and this lets you know what protocol is included in what package. We will select package 01. Now you'll notice you can generate the 3D view. Swivel it around, and it shows you your power supply, your 1 single Ethernet connection with 3 inputs, 3 outputs, your additional input-output board, 3 mic spots. So if you need to upgrade later on, as I mentioned earlier, you can add a board in the field by simply updating the settings file. If you have to update firmware, we can send a encrypted firmware update to you in the field that you can update to the relay, and then your T3 board with the 4-channel voltage, 4-channel current. There's also an item here where you can generate a guide form spec. So once you go through the selection, you have your style options. There's additional information available on the BE1-FLEX product page, like 2D and 3D CAD drawings, other information. So for this typical feeder application, I'm going to use our BestComms Plus software and the style configurator in the software to do our selection for this particular application, and a quick typical settings file for a feeder application. So here's our BestComms Plus software. Metering Explorer and Settings Explorer. I'm going to remove the Metering Explorer and just demonstrate on the Settings Explorer tree and navigate to the Style Configurator. It automatically has a base style in there. You can edit that and put in the particular options for your application by moving the arrows up and down and changing the quantities. So for this application, for 3 voltage phase inputs, we will use the 4-channel voltage and 4-channel current for the 3 current inputs for phase A, B, and C, which is a T3 card. Typical input-output board, I will use the W9, which has got 5 inputs and 4 outputs, 2 of them form C. For communication boards, 1, 2, or 3 Ethernet port options. For this option, we'll use W2, which is 2 copper inputs, RJ45, with 3 inputs and 3 outputs. We'll assume a 24 volt DC power supply. We'll use the intermediate protection package because for this particular settings file, I'm going to be doing some voltage and current protection elements both. And I'll keep the package at 01, which includes for protocol, Modbus, and DNP3. So after you're done making all your selections, the first thing you do is auto-generate instances. And what that does is it maps out circuits, inputs, and outputs based on the hardware and firmware you selected for your particular application. So notice now I have a circuit here. And we will go into the circuit and navigate to the hardware tab, and it shows you that I'm looking at slot 7 VA, B, and C, and the currents IA is slot 7 I1, IB is I2, and IC is I3. You also have to put in some power system parameters. You can also give it a name if you want. So for instance, if it's 2000 to 5 CT inputs for the 3-phase CTs, you would put in a value of 400. And if it's a 480 to 120 PT input, you put in a ratio of 4. 60 hertz, 5 amp input is the default. 4-wire Y is the default. If you need to do 3-wire delta, you just use the drop down to change and make any changes. Everything else you can leave as default if you're not using the ground or the VT or CT. So that's a setup for the power system. Any inputs and outputs, notice it maps them out by slot 2, input 1, and goes down to input 8 total. And then the outputs, you can label, and it's mapped as well based on the slot and the output on that slot. For the general device information, you can put in a label and give it an HMI file that you can use on the home screen. We will do some protection elements, a typical undervoltage. We'll do an overvoltage. Notice you have 255 of each of the elements available. So there are a lot of elements available to be used on the relay. I will add a instantaneous overcurrent, and a time overcurrent, and we will add 2 frequency elements as well. You can give these unique labels if you want. Notice when I created the element, it automatically enabled fault recorder. So it will record a fault record when there's a trip event. Select the mode, so I'm selecting phase, and I'm selecting the source, and one of 3 is the method. The block on F60FL is enabled automatically, and then you put in your pickup in primary or secondary value. When you put in the secondary, it automatically puts in the primary value for you, and any inhibit if you want, and any time delay. So I'll put in a 50 millisecond time delay. When I go back, you notice the legend changed when I updated the element. We'll do the 59 next. Again, we'll select phase for the mode. Select feeder 1, 1 of 3, and put in the pickup level and a time delay. Similar for the time overcurrent. Time delay again, and then direction if you want to use directional. 51, time overcurrent. Here again, selecting the source, the pickup level, time dial, and you also have to select the curve type from any of these curves. Down at the bottom is a table curve, so you can do a custom curve. I will assume that this one is standard inverse curve. And then voltage restraint or control if you need to use those functions as well. So we'll do the over frequency next, feeder 1. And again, a small time delay, and it automatically has a inhibit in there for you if you want to use that. Use the under. Put in the setting. And a small time delay again. And then I have all the settings put in for the different elements. Now I got to create the logic using the best logic tab. Simply drag and drop the different elements. Notice there's a drop down arrow that gets you to the advanced features if you need to use them. Simply drag and drop them all on the page, and you notice they go to dark gray to let you know that they've been used on the logic page. So now I'll use an OR gate and connect all of them to the OR gate. So any one of these will trip the breaker. You can leave notes. So you can leave any notes for the technician or operators. And I will select the trip output. Connect that. Notice everything goes to green down there with the LEDs. Save the file. You can test your logic with the offline settings simulator. Here's the legend. You can, if your logic gets with a lot of it on the page, you can test it to make sure it's working like it's you envision it. So after that, you're ready to save your file and then upload it to the relay. So we'll go through the example. So again, you configure the style like I did. Generate the configuration with the auto generate. Name the circuit. Put in the CT and PT ratios. Enable and create those elements and put in the settings and drive the outputs. In the background again, it automatically enables the targets, the critical alarms, the oscillography capture with standard ComTrade files, sequence of event, security log, and our latest feature, the chart recorder, which was added as part of our advanced motor protection functions, which were released this week. So the next example is low impedance bus differential. It's used to clear faults quickly, does not require any external coordination. There are two types, low impedance and high impedance. The BE1-FLEX uses low impedance protection. The high impedance CTs are externally wired together and impedance is measured to detect a fault. And this requires dedicated CTs for the high impedance function. And it's unable to see the current on any individual feeder or source. So it's a little bit quicker, but they're both fast. The low impedance, the BE1-FLEX provides low impedance bus differential, as I mentioned, operates typically in less than 2 cycles at 5 times pickups. The CTs are brought in directly into the relay. So for instance, if you have 5 breakers, a main and 4 feeders, you would wire the CTs in on all 5 of those breakers. This also allows for other protection and metering functionality, assuming you have a PT input depending on the hardware limits. So you can also have all the other protection because differential will be enabled and you'll have full current, voltage, and power metering as well. So differential basically looks at the current entering and leaving his zone, and when the operate current ratio to the restraint current is high enough, it will trip the breaker. This drawing here is healthy with no faults, so the operate currents should be very minimal. There will be some difference because no system is an ideal system, but in an ideal world, this would be no operate current. When there's external fault, the restraint current is high, so the operate current to restraint current ratio will typically be under the curb so it won't trip. When it's inside the zone, then the operate currents, notice here on the current flow with the vector diagrams showing where they're operating, you'll notice that then when the operate current gets high enough based on that fault, it will then initiate a trip. So here is our low impedance bus differential application. So you got the main breaker here with three-phase CTs. You got your three-phase PT, so you can have metering for all of these different breakers. And then you wire in the 3 feeders. So again, you use the configuration tool to make your selections. So again, we'll go through that particular for this. We'll refresh the website here. So you make your selections. I need a T3 for the voltage and current, and I need some more voltage inputs. So I'll have a total of 18, so I'll have some spare, W9 and E5, so I have 8 inputs, 7 outputs. So I got enough to, maybe I want some extra outputs here so I can control all 4 breakers. And you go through your power supply. You need enhanced for this particular application. And then shows you a fully loaded relay with the flex with no spare slots. So here's the recommended selections for that. Again, the T3, the 2X, the 1X6 and the L6. I selected in mine 2X6 because the cost difference is not much. So you might want to optimize and have some extra spares. Same with the extra output contacts, because I had the available slots. You can put that in, but you don't need to. The enhanced protection, the copper Ethernet, and Modbus and DMP. Then you go through, create your setup, and you build your logic here with the 87 for the unrestrained and the restrained trip going to output 1. And you also put in your protection, etc. Next example is a generator with a generator step-up transformer. Notice there is a generator circuit breaker and a high-side transformer breaker. This limits and prevents damage to the generator, the prime mover, and the transformer. You can control and supervise generator synchronizing and breaker operations. You can also do instantaneous phase overcurrent, ground overcurrent for both instantaneous and time overcurrent plus differential. And it can also do synchronization. Here is the connection. So starting at the top, you have your line to neutral connection for your VX to do your sync check or auto sync. You have your high side CTs for the transformer and also protection for this breaker, which is the high side breaker. Then you have your 3-phase on the generator side. Typically here in between the generator and transformer, you possibly could have a set of CTs there as well. And then also your 3-phase PT input for your voltage measurement and voltage protection for the generator. So again, you go through the configuration tool and the style selection. For this application, again, we need the T3, which is the 4-channel voltage and 4-channel current. We need a X6, which is 7 additional currents, so you have a total of 11. Communication board, E5 with 3 inputs, 3 outputs. The W9 and your power supply 1 again. You're enhanced because you're doing differential, and protocol package, just assuming no IEC 62150, including Modbus and DMP3. So here's your style and your options. This is typical protection that would be used. Note we have a generator application guide and a transformer application guide if you need more information on consideration for those types of protection. So reverse power, loss of field, your thermal protection with the 49TC or the 49RTD, both are available. Uncleared external fault with the 51, overexcitation, and invertent energization, which is done via logic. We have logic templates that you can get from our product page on the BE1-FLEX product page. Negative sequence overcurrent protection with negative sequence via 51 or the 50 element. Off frequency operation and voltage balance supervision with the 59 element and 3V0 using that mode in the 59 element. And then last but not least, the all-in-one, where you have a main breaker, a generator breaker, and 2 feeders. So for this particular application, you need the 3 T3s and an X6. So 4-channel current, 4-channel voltage, and 7-channel current, along with a W9 and an E5 that gets you 8 inputs, 7 outputs, along with your power supply and the enhanced protection again, and the protocol package 01 with Modbus and DMP3. So application calls for a 3 backup generator, 3-phase backup generator, bus voltage and utility voltage. So 9-channel voltage being used. 3 sets of generator and transformer CTs. So that's 9 current inputs. 2 feeders and 1 main CT there. You have the analog boards utilizing the 12-channel voltage, the 18-channel current, the W9 with the 8 outputs and the 7 outputs and the 8 inputs, along with the copper Ethernet and the enhanced protection and protocol package. Then you build and create your logic. Notice, as I noted earlier, it can become very complex, so you can leave notes and other items on there. And then last but not least, quickly show the HMI interface here. The HMI interface for that particular application, notice it has 6 control push buttons that can be used here that are on the home screen. Additional available on the submenu. Same goes for the indicators. You can have a dozen on the home screen, additional available. You can use those to make a particular control action. I'm simulating alarm so you can see the control banner. You can then select that red banner to navigate and reset the alarms or targets. I can also close the breaker and see the status of that breaker I am controlling. You can look at real-time data, voltage and current via the phasers, phase to neutral, phase to phase, or sequential or ground. Select the source, primary or secondary, and what you want to read, whether it's impedance, voltage, or current. Click on the home screen, and you're back to the home screen.